Hi everyone, welcome back to Easy Chemistry by Vanilla. So this is the continuation of the NTPC previous year paper. Next question. Match the following. Here they given the types of solids and examples are featured. Crystalline solids. Crystalline solids have particle arranged in regular and long range repeating pattern. Next, amorphous solids. These amorphous solids are also commonly known as polymeric solids. So this is of polyethylene. Next, polycrystalline solids. These polycrystalline solids are aggregate large number of small crystals or grains. It consists of many small crystal joined together. Next, molecular solids, dry ice, that is solid CO2. Crystal held together mainly by intermolecular forces. So, correct option is third one is the correct one. Next question. Identify the correct statement among the following. Most engineering materials are crystalline in nature, which give them higher strength and density. Also amorphous, not only crystalline. So this is wrong statement. If an amorphous solid is maintained at a temperature just below its melting point for long period of time, the component molecules, atoms, ions gradually rearrange into a more highly ordered crystalline form. Yes, these are amorphous or thermodynamically metastable. So this is the correct statement. Why these two are also wrong? Repetition along translation axis only is the true measure of symmetry in a crystal. No, not only translational but also rotational, reflection and inversion. So this statement is incorrect. Next, atomic packing factor of a simple cubic crystal is greater than body-centered cubic crystal, making it is a more efficiently packed material. No, because BCC is greater than simple cubic, because BCC has 68%, simple cubic has 52. So that is why this statement also incorrect. Correct option is second one. Next question. Arrange the following material increasing order of the strength of their magnetic property. Mainly here magnetic properties are diamagnetic, paramagnetic and ferromagnetic. Here they given gold is a diamagnetic. Aluminium, manganese. These two are para. These are ferro. So what is the correct arrangement? So the increasing order is gold is less than, aluminum is less than, manganese is less than, iron or silicon, and finally nickel, iron. So this is the correct answer. Identify the correct statement among the following. In case of extrinsic semiconductor, the Fermi energy is independent of temperature and lies between conduction level and donor level for n-type and between valency band acceptor level is p-type. Here they given independent. No, it is dependent on temperature. So that is why the statement is incorrect. Intrinsic semiconductor is the pure form of semiconductor. When sufficient energy is supplied to electron in conduction band, they absorb energy and move to valency band, leaving behind a hole. Here, valency band gains sufficient energy. It moves from the valency band to conduction, leaving hole in a valency band. So here they given conduction to valency. That is why this statement is incorrect. The phenomena in which magnetic field are completely expelled from the interior of the material during the transition from normal conducting state to superconducting state. This is known as Messner effect. Yes, this is absolutely correct statement. Whenever you see the Messner effect, this is completely expelled and superconducting. Next, the resistivity of impure metal will not have any resistant value at absolute zero temperature and remains independent of the temperature of the material. No, it is dependent on temperature. So that is why this statement also incorrect. Correct option is third one. Consider the following types of solution. CO2 gas in water. CO2 reaction with water, it form carbonic acid. This is a strong interactions. Next, natural gas, that means methane. This is hydrocarbon. Here non-polar, this is weak interactions are present. Next, naphthalene in water. Naphthalene is a non-polar. Water is polar. So here also weak interactions are present. Next, palladium H2. Metal and H2. This is a strong because hydrogen bond is present. Next, ethanol in water. Ethanol, which is nothing but alcohol, OH group is there. Reaction with water. This has strong hydrogen bond. So, what they given the question? Select the option that represent increasing strength of interaction between solute and solvent. First, what is this? First one is the naphthalene in water. Second one is natural gas. Third, metal with hydrogen. Fourth, CO2 in water. Next, finally, ethanol in water. Here, this has strong hydrogen bond. This has strong interactions are present. Correct option is fourth one. Next question. Consider the following IUPAC names of some organic molecules with their structure provided in the table below. 3-hydroxybutanol. 3-hydroxybutanol. Butanol means 4 carbons are present. Hydroxy means 1 OH group is present. So check here which one is correct. See this one. 4 carbons are there. Butanol, aldehyde group is present. 3 hydroxy. 1, 2, 3, 4. 3 hydroxy. So this is the correct one. Next, 2 amino butanoic acid. 2 amino. Butanoic means 4 carbons are present. Oic acid, which is carboxylic acid, is present. So which one? See here. 4 carbons are there. One is oic, second is amine. So 1, 2, 3, 4. 2 amino butanoic acid. So this one. Next, 4, 5 dimethyl 2 hexene. 4, 5 dimethyl. Hexene means 6 carbons are present. See, 3, 4, 5, 6 carbons. 4, 5 dimethyl. This is 4, 5 dimethyl 2 hexene. Here it is double bond. So it is 2 hexene. This is the correct one. Next, 3-methyl pentane 2-one. 3-methyl. Pentane means 5 carbons. See this one. 1, 2, 3, 4, 5 carbons are there. 2-one, which is ketone group. 3-methyl, this one. So correct one is first one. Next, 2 amino pentadioic acid. So finally this one. This is glutamic acid. Here RS configuration they mention. RS configuration is the separate topic. I will explain in upcoming topics. So correct option is the first one. Next question. Consider the following. Here Cr3COO minus H and C6H5O minus CHR2. Select the option where the group arranged order of decreasing plus I effect. This is ERG. Plus I effect means ERG. What is the order? Is greater than, NH is greater than, O is greater than. This is the order. If you know this order, you can easily answer the whatever the given question. You can answer very simply. Isopropyl, ethyl, methyl, and finally hydrogen. This is the order. So check the order here. So first one is C6H5O minus is greater than COO minus is greater than Cr3 and CHR2 and hydrogen. This is the correct order. Next question. Which of the given statement not correct for the molecular shown here? Here they given the molecule. So can see the options. The effect on bond length was the result of the S character of the saturated carbon rather than neutral hyperconjugation. The main interaction between the methyl group and the ring system is positive ion aromatic hydrocarbons is due to hyperconjugation rather than inductive effect. No, this is also incorrect. Hyperconjugation appears to operate for both carbon hydrogen in various systems supported by quantum mechanical studies. This is also incorrect. Electron release in hyperconjugation is permitted by mechanism that is essentially the reverse of tautomeric effect where dipole is generated by canonical form. They given the question is not correct. So this question is not correct. So correct option is this one. Here mainly it is the hyperconjugation. That is sigma electron donor pi system MTP orbital. It represents mainly no bond resonance, not by the saying it is reverse of tautomeric. Not by the saying of tautomeric. So that is why this statement is wrong. So our question is not correct. So this option is the correct one. Consider the following statements. According to Hoffman rule, electron withdrawing groups in the beta position make elimination reaction more preferred to substitution and shift the mechanism towards the even CB end. A more basic nucleophile are base with higher energy HOMO and more acidic substrate with a lower energy LUMO interact more strongly in E2 or SN2 mechanism. According to this activation strain model, electron withdrawing group stabilize the beta carbanion. EWG at beta carbon. Next it has beta hydrogen become acidic after carbanion stabilized. Next even CB character increases. Next electron withdrawing group is acidic hydrogen and elimination increases, even CB increases. So finally HOMO high and LUMO low. This is the strong interaction. So these two statements are correct. Third option is the correct one. Next question. Consider the following carbanion. N-propyl, cyclobutyl vinyl, cyclopropyl, neopentyl ethyl. Arrange these in the decreasing order of their stability. So first one, that is vinyl because of sp2 hybridization. Next one is N-propyl carbanion, that is CH3 CH2 CH2 minus cyclobutynyl, that is CH2 CH2. Next one, cyclopropyl. CH2, CH2. This is the cyclopropyl. Next, this is the neopentyl carbanion. Next, ethyl. CH3, CH2 minus. So, what is the correct order? First one is the vinyl. Second one is cyclopropyl. Third one is ethyl. Fourth one N-propyl. Next neopentyl and finally cyclobutyl. This is the printing mistake. They given increasing order but our question is decreasing order. So correct option is first one is the correct one. So this is the end of the today's session. Further questions we will continue in next section. Thanks for watching.